Okay, next question. Notice that the large margin of error that we have a margin of error of 17.2%, 0.172. I typically, and most stat nerds, don't want a margin of error that high. We typically want a margin of error about 3% to 5%. So the purpose of this particular problem is, let's say we, a goal, reduce the margin of error to 3%, down from the 17.2%. So what sample size would be needed to accomplish this? Well, it's the same formula. We still have the same 95% confidence interval, so the 1.96 applies. We still have the same estimate of p hat. We still have the same value for 1 minus p hat. And the only difference is we want the margin of error to be 0.03 squared. And not 17.2 squared. So you may already have this in your calculator. If you do, just make the change of 0.172 to 0.03. Okay. Getting a syntax because I have something. And when I do that, I get the following. So to give you an indication, let me go back up and show you what I have. So I have from left to right, I have 1.96 squared times the p hat, 0.304, times the q hat, or 1 minus p hat, and then I divide by my desired sample size, which is 0.03 quantity squared. So I always round up sample sizes so I can meet the desired outcome. 903 wouldn't meet it, but 904 will. So my sample size would have to be increased by quite a bit to 904. All right. Again, just a simple manipulation of this formula. If you can put this in your calculator without doing a typo or something, those are pretty easy. Because I did the work for you, right? I created the formula. All you got to do is be able to use it. Now, the third type of problem that we get into is, absolutely nothing is known. And so with nothing being known, we have to take a little different approach. So no estimate of P, which of course would be our P hat, is provided. So what sample size would we need? So let's say that we have a desired 90% confidence interval. Just change things up a little bit. We're so focused on this 95% and the 1.96 is the Z critical. Let's change it up a little bit. And for the 90%, we know that the Z critical is 1.645. All right. So what sample size would we need? Now the formula that we use here is a modification. So we have still our Z squared, but now we use a constant of 0.25, and then the margin of error, of course, squared. So it turns out to be quite a bit easier. I'm really annoyed by this screen jumping around everywhere. So in this case, our Z would be, of course, 1.645 times 0.25 over our desired margin of error. That's just going to fluctuate from problem to problem. So let's just say that we want the 0.03 or the 3 plus or minus 0.03 for the margin of error. So we're going to have 1.645 squared times the 0.25 divided by the 0.03 squared. So I get 752 as the desired sample size. So that's what I get right there. All right, I'm not really sure. I have to be in complete transparency. I've never seen this uh, as an option until I used this textbook. I'm not real crazy about it, but there are going to be some problems like this. The problems that I run into are much more similar to questions 1 and 2, where I have information, I have a confidence interval, and I need to calculate the sample size that was used, or I've got a situation where I want to reduce my margin of error and calculate the sample size there. I don't think I've ever seen this in the real world, if you will. All right, that's all I got. Take care.